Welcome, everyone. I'll give the people who are coming in right now just a moment to get settled. You can't hear me online. Okay.
But I don't know, maybe it needs to be started.
Oh, I don't know. I think he's the guy in the back is controlling our Zoom, so maybe once we get going. Can you chat with them and see if they can hear me? Good afternoon, everyone, and welcome to session B3. My name is Ashley Jester. I'm the Associate University Librarian for Research and Learning at Boston University, and I'll be the session chair for this afternoon. We have 4 great presentations today. Each group is going to speak for about 20 minutes, and we're going to reserve the last 10 minutes for questions. If people end a little earlier than their 20 minutes, we can take some questions between presentations as well. I'm just going to get us started so that we can stay on time. So our first speakers today are Louise Capener and Nadia, Kennar. Louise and Nadia are research associates at the UK Data Service. They work within the computational social science team, where they aim to encourage fellow social scientists to adopt computational techniques to enhance their research projects. Louise and Nadia will be presenting on exploring sex, sexual orientation, and gender identity through interactive visualizations. Please welcome Louise, who's going to speak first. My brain is not here.
Can we all hear me all right? Yep, thanks. Hi everyone, my name is Louise Capener and I'm a research associate at the UK Data Service. And today we're going to be exploring sex, sexual orientation and gender identity through interactive visualizations. I'm also joined remotely by my colleague Nadia Kennar. Not attending today are our other 2 contributors, Kasmire and Alle. So first we'll start with a bit of background on the existing research around gender identity and sexual orientation. Then we're going to go ahead and take a look at the 3 visualizations, and finally there'll be a bit of time for a Q&A at the end. Also, just to note, there's going to be 4 QR codes that are going to appear on the screen throughout this presentation, which link out to the visualizations and the GitHub repo, so you might want to have your phones out and ready. Okay, so prior to the 2021 UK census, relatively little research addressed the UK's sexual orientation profile. For example, sexual identity information was collected in NatSal, Understanding Society, and the Health Survey for England, but not at lower geographical levels, and often with quite limited samples. The ONS also produced experimental statistics on sexual identity, and they've done this using data from the annual population survey. This data actually is provided at local authority level, but it's considered to be unofficial as it was created primarily to assess methods. When it comes to gender identity, there's even less data available. Some relevant questions have been trialled in various UK surveys, but the best estimates that we currently have come from admin data, such as higher education. Internationally, though, we do see some questions on gender identity in various censuses, including in Canada, India, Nepal, and Pakistan. So in order to catch up with that international research, the following questions were added to the 2021 UK census. Both questions were voluntary, and the wording did vary slightly between the different countries. The census also allowed respondents to request an individual form that would be kept confidential from the rest of the people in the household. So now we arrive at the main question then. So why bother making interactive visualizations of this new data? Well, the census data provides a novel opportunity to visualize these topics at a low-level geography and with a very large sample size. And whilst the ONS did create some really cool interactive maps on these topics, their maps are currently only single variate. So for us, this was a great opportunity to build on that work. Low-level geographies, large sample sizes, and multivariate data can make for complex data. So we wanted our visualizations to permit explorations that are going to increase user understanding of this data. So you can see at the bottom right here, we've got our first QR code. That's going to take you to my interactive scatter plots and tables, which I'm going to show you in just a minute. The interactive visualizations that I've worked on focus on non-response rates. As I've said before, the census questions are both novel and they're voluntary. Furthermore, the question on gender identity is probably going to be less familiar and less clearly worded than that sexuality question, and respondents might not answer these voluntary questions that they don't understand. In that sense, I decided to focus on main language and religion as factors because these two can be closely tied. For instance, Islam is closely tied to the Arabic language and Sikhism to Punjabi and so on. So what I hypothesized is that the non-response rates are going to be different between respondents whose main language isn't English. And I further hypothesized that we're going to see different non-response rates between the two questions, and that's partly due to that wording of the gender identity question. Just a little brief note on my computational environment. So I wrote my code in Python on Jupyter Notebook, and I deployed the visualizations to Heroku, which is a cloud-based platform. But please do get in touch if you want more details about the tools that I've used. Now let's take a look at these visualizations. So I'm just going to switch the screen. Here we go. Okay, so the scatter plots for sexual orientation are on the left, and for gender identity, they're on the right. And these first two show the relationship between the non-response rate and the percentage of non-English speakers in different local authorities. Sorry, it's quite difficult to scroll down to get them both showing exactly. There we go. Okay, and I chose to display them side by side like this, just so you can get an idea of whether the findings differ between the two. Bokeh, which is the package that I used to create these graphs, has lots of really cool interactive features. So for instance, if you hover over a data point, you can find out some extra information. So we can see what local authority it refers to. In this case, we have Brent. You can also see the specific X and Y values too. So for our gender identity data set here, we can see that Brent has the highest non-response rate at around 10%, and 32.49% of its inhabitants don't speak English as their main language. Also, you can see its place in the data set too, which is represented by its index number. There's also a drop-down, so you can switch between data points by region, by the urban and rural classification, and also by something called the Shannon Index, which is a measure of religious diversity. And a really nice feature of the region and the urban plots is that they have these interactive legends. So if we look at the region plot, we can remove some regions to reveal some interesting patterns. So I'm just going to go ahead and let me put my notes down for a second. Let's try remove some of these. All right, keep going. Okay, so you can see for London, there's a fairly positive relationship between that non-response rate and the percentage of non-English speakers. Whereas with Wales, we've got this sort of like a cluster of data points in quite a narrow range of X values, but quite a dispersed non-response rate. Let's scroll down. And here we have our second set of scatter plots, which focus on the relationship between different religious groups and their non-response rates. So if we have a look at the Islamic non-response rate for the gender identity data set here, let's give that a second. I'm just going to scroll down so we can see that clearly. You can see that there's quite a positive and strong relationship outlined here, which is quite interesting. So you'll remember that before I mentioned when I started looking at the census data, I thought I might observe much higher non-response rates for this community for this particular question due to that association between religion and language. Whereas I thought for the sexual orientation question, I'm not going to get as strong or as positive of a relationship. So we can check it out here. Let's see. I'll just try and line that up again. So you can actually see that we've got quite a similarly strong relationship here. And if we go down and look at these data tables, we can actually verify that the non-response rate for the sexual orientation question is actually slightly higher than the non-response rate for the gender identity question, which is not what I expected to find. And we can also check out some other religious groups. Let's have a look at Judaism. So we can see that there's a much less clear relationship shown here. And in fact, this graph is actually quite difficult to examine because of this tight cluster of data points here. Luckily for us, we can use the wheel zoom function in Bokeh's toolbar. So it should let me pan around, and let's see if I can try and zoom in a bit. Oops, there we go. So you can get a closer look at those data points. There is also something called box zoom as well. So you can actually draw over the portion of data points that you want to get a closer look at, and it will zoom in for you. You can hover over and check out which local authorities are there. Then if you played around and you feel like you've got a bit lost in the axes of a graph, you can use this handy reset button here, and it's going to get you back to where you started. Finally, I'm just going to draw your attention to this brief section on the relationship between non-response rate and sex for each data set. So we can see here that we've got a slightly higher non-response rate for females for the sexual orientation question, and that relationship's flipped for the gender identity dataset. Expanding on these links between sex and these two datasets is going to be the next step for me in this project, so do stay tuned if you're interested in that. What I'm going to do now is pass you on to Nadia, but do feel free to play around with these visualizations in your own time and see what else you can infer from the data. So, okay.
So, in this second part of the talk, I'm going to walk you through using Shiny as an interactive tool for exploratory analysis. Again, I'm working with two datasets from the census 2021 and exploring the distribution of these categories across urban and rural areas. Now, regarding my program language, I have been working in R and its IDE R Studio, specifically using the Shiny web application. The code can be found on our GitHub link, which we'll share at the end of the talk. But for those R enthusiasts, the main packages include Leaflet, Tmaps, ggplot, and Shiny. Currently, the app is deployed on the University of Manchester's pilot Shiny server. And due to working with extremely large shapefiles and complicated spatial data, I've had to create two separate apps in order to explore these trends separately. So I'll be demonstrating the gender identity maps, but feel free to explore the sexual orientation maps in your own time as the servers follow the same structure. But let's go ahead and dive in. So here is our Shiny app. I've made it where we can explore these distributions across two packages, that being Leaflet and Tmaps. So let's first explore the Leaflet map. The Leaflet map is one of the most popular open source JavaScript libraries for interactive maps, and it provides a great tool for exploring and analyzing your data. So let's start by exploring whether gender identity is the same as sex registered at birth, which is the first category defined by the ONS. And let's go ahead and analyze this distribution and its relationship with urbanization. The table below the graph indicates the proportion of individuals falling into each category relative to the total count. So according to the table, the percentage of individuals whose gender identity matches their registered identity at birth in rural areas is 18.64%. When we compare this to the rural areas, the urban areas, this number skyrockets to 60.24%. So the percentages suggest that the distribution of individuals with the same gender identity as sex registered at birth differs across urbanization categories. The percentage of individuals in urban areas whose gender identity matches their registered identity at birth is higher compared to rural areas, which is a really interesting find. We can also go ahead and explore our second categories, which is gender identity different from sex, registered at birth, but no specific identity given. Quite a mouthful. In this instance, we'll just have to wait for the map to render. Again, we're working with very large spatial data frames, so this is something that's just bound to happen. But we'll just give that a couple seconds. There we go. So in this instance, we can interpret that there may be a relationship between urbanization and this gender category. So what we're seeing here is that the percentage of individuals in rural areas who have a gender identity different from the sex registered at birth, but no specific identity given, is at 9.15%, which is a little bit higher than the category we've seen before. Where we compare this to the urban category, we're again also sitting at a higher percentage of 77.36%. So from these results, we can interpret that there may be a relationship between urbanization and the presence of individuals who have a gender identity different from the sex registered at birth, but without a specific identity given. These findings suggest that the urbanization status may be associated with a higher proportion of individuals who have a gender identity different from sex registered at birth. However, similar to the previous interpretation, it's important to note that these results provide an overview and do not imply causation. So further analysis and exploration are needed to understand those underlying factors and dynamics contributing to this relationship. Another feature that's pretty cool in this map, which you may have just seen me do a couple of seconds ago, is that we can change the number of colour breaks, also known as the bins. So if you change the number of bins from, let's say, 5 to 10 when creating a map, it would result in a more granular representation of the data. And this map would have a more distinct colour graded ranges to represent different intervals or categories, as we can see here. You can also specifically choose an area type, so you might be specifically interested in those urban or rural areas. And there's also an option to choose a specific region. Now, although changing the number of bins is one way to obtain a more granular representation of the data, we can go one step further and apply classification systems to our maps. In T-maps, a classification system simply refers to the process of dividing continuous or categorical data into distinct classes or categories for mapping purposes. And the classification systems in T-maps basically determine how data values are grouped and assign colours or symbols onto a map. So we can go ahead and explore that first quantile classification system. The map's taking a little bit long to render, so what I have done is just screenshotted an example of what this would look like. But the quantile classification method divides the data into equal size groups, ensuring that an equal number of observations fall into each group. And this method is useful for identifying patterns or clusters in the data. Additionally, we could change this classification system to there we go, it's rendered now, typical, but we can also change this to a different classification system to see how the groups change in the map. So I'm going to go ahead and just change this to Jenks. Jenks is also known as natural breaks, and this method basically aims to find natural groupings in the data by minimizing within group variation and maximizing between group variation. And this helps to identify distinct clusters or patterns in the data. But overall, by incorporating these alternative classification systems, you can demonstrate how different classification methods can lead to varying interpretations of the same data set. And the choice of classification systems can influence the perceived perceptions, concentrations, and distributions of the data on the map. It highlights the importance of selecting appropriate classification methods based on the data characteristics, research questions, and desired representation of the data. Evidently, this is taking a little while to load, so I will just show you a second screenshot from the Jenks classification system, as seen here. But that draws conclusion for my demonstration. Thank you all for listening in to our talk. We hope that we've provided you with some inspiration for interactive visualizations. Feel free to check out our references as seen here. And feel free to get in contact with us if you have any questions, concerns, queries, or comments. And all our code is available on GitHub. But I guess I'll leave the floor open to any questions.
We do have time for a few questions if anybody has one. I don't know if there's anything online. I don't see any in the Q&A.
Don't worry if you don't.
Just asking.
Yeah.
Okay, I thought you had your hand up. No, it's okay. All right, well, then I think thank you to Louise and Nadia. That was wonderful.
Thanks, everyone.
Round of applause for them.
Thank you, everyone.
So, while our next speaker is getting queued up, I will introduce him. We have Pascal Ziegers. Pascal studied social sciences at the French-German study program at the Institut d'études politiques, Sciences Po, I don't speak French, de Bordeaux and the University of Stuttgart. Afterwards, he was a doctoral student and researcher at the Central Archive for Empirical Social Research at the University of Cologne. From 2008 to 2011, he received a scholarship, the German Research Foundation, within the framework of the research training group, Social Orders and Life Chances in International Comparison. From 2011 on, he worked as a researcher at the Institute for Computer Science of the Heinrich Heine University, Dusseldorf. In April 2013, he joined GESIS, and since October 2014, he is managing the Research Data Center for the German General Social Survey. From October 2017 to October 2020, he has chaired the Research Data Infrastructure Committee at the German Council for Social and Economic Data, RAT-SWD. Pascal is going to be speaking today on linked open research data for social science, a concept registry for granular data documentation. Please join me in welcoming Pascal.
Thank you very much for this very nice introduction. Not sure if you see the right screen because I don't have a red bar around it. Could you give me just a short feedback if you see the presentation instead of the program? Okay, so James, the screen means the presentation screen, right? With the title of the presentation. Anyway, I'll start. What we are currently doing, and this is partly a consequence of my work that I have done as the chair of the Research Data Infrastructure Committee, is that we identified some problem that we saw in data documentation, especially regarding data search, that is that we have a missing link in data documentation currently in the research data infrastructure in Germany, at least, and I think it's internationally still unsolved. So our point is that we have more and more valuable metadata available for a granular documentation of especially survey data. So we have good metadata on the data sets. We have codes and labels of variables. We have very good metadata on questions and question wordings. We have, in some cases, links between the measurements in the surveys and the data and some very general topics. For instance, many CESTA archives use CESTA topic classification, which has a kind of limited number of categories, but helps in organizing the data. What we don't have in our data documentation, not at GESIS, and to my knowledge, only in few exceptions, very nicely documented longitudinal studies, is that we have the theoretical concept linked to the data in the metadata. And if we think about the verification of data, of survey data, then this is an issue, because if you look for data that is different in the measurement but similar in the concept, it becomes very burdensome, and you have always to think about what kind of search terms are appropriate to find data that fits the theoretical concepts that you are looking for. And one of the reasons for this is that research data infrastructures, at least in Germany as I know them, did not know how to manage the diversity of theoretical approaches and conceptual terms. And what we do need for this is a kind of common vocabulary that summarizes theoretical terms that we use when we do research. So what we have available is the lower part that is in the figure. Common metadata standards have been implemented. We have DDI and it works quite well. What we do not have, or not for a theoretical part of our data, is the common vocabulary. So we have the DDI CVs, but we don't have a CV for theories. And what we know about our users is that they generally start searches with general terms, topics, or theoretical terms, which then end up in very frustrating research results. So we formed a large group of people, and we just thought, okay, let's try to get a system that might work for this missing link of data documentation. And we started to work together, and we started to explicitly work on the topic or with the concept of concept itself. And in the social science research, there is a lot of thought done about what concepts really are, because they are defined in very different terms. But what is clearly a consensus is that the scholars theorize about reality in terms of theoretical concepts. If we talk about gender identity, this of course is not a reality per se, it's a scientific concept about how to talk about the realities that we observe. So we have a kind of basic level concept that is rather abstract, it's definitely not covered in the data. We have to transform our concept into an observation, and the step that we have is first, of course, defining the concept, maybe defining the different components that this concept is made of, and then specify rules for observation, which in survey research are simple measurements of questions. And this multi-level and multi-dimensional concept of concepts has been theorized by Gertz, and he distinguished 3 different levels of concept: the basic level and the secondary level concepts. And what we have is metadata about the indicator level. What we lack is metadata, or structured metadata, about the basic and secondary level, because we don't have an ontology that gives us all the terms that we would need. And especially the thesauruses that have been developed for the documentation of literature are not very well suited for data documentation, because they use only the basic level concepts and most often lack secondary level concepts. This is an example of a concept that is very popular in political science over the last 10 years. It's populist attitudes, and here you see the clear Gertz structure. The example stems from the German longitudinal election study. You have populist attitudes, everyone talks about populism, but in fact they are talking about 3 different components or dimensions of populism: anti-elitism, popular sovereignty, and virtuousness of the people. And then you have a couple of questions related to each of these dimensions, which is the operationalization that is transformed into an observation. And for each of these dimensions, you will find a multitude of different operationalizations. So in the end, when you are going to search for data, you have to know the question items and the wordings of the question items, because the concept populist attitudes might be included in the study descriptions, but most often the mapping of the questions to the different subdimensions of the concept is not included in the data, or only in the variable labels. And this is not very easy to find. So what we have is diversity, that is the rule rather than the exceptions, diversity regarding the theoretical vocabularies that are used, diversity regarding the measurements. And so we have a lot of end-to-end relationships between concepts and measurements. And this is the challenge that we have to overcome, or that we try to overcome. So what we thought is that we start designing a concept registry where people can register the terms they use when they talk about their own data, not at the measurement level, but at the theory level. So, and this is maybe the new point that we want to try, is that we have a user-driven and open vocabulary where everyone can contribute to the vocabulary. And what we aim at, which is difficult in the end, is that the theory language is the reference for this concept vocabulary, and not the measurement vocabulary, which is already in the metadata, because we have good metadata about question wordings and labels and codes, etc. And this concept registry should be included into the existing linked open data infrastructure, because we have thesauruses like the Thesaurus Social Science, or the ELST that is hosted at the UK Data Archive, so that we can model the relationships between the terminology that the researchers use in everyday life and the existing LOD resources, in order to structure a little bit what happens. And what, of course, is required is open interfaces for reuse of the concepts. So we designed a prototype to some extent that has 3 components: a data model for the concept registry. This is important so that we can do the programming work in a meaningful way. An annotation tool, which allows you to link concept to the metadata, and a triple store that is there to manage the different relationships that we define. I'll start with the first, the data model, which is very easy because what you see here is that we reuse a lot of concepts and categories that are existing in other linked open data resources like SCOS, DISCO, etc. So we have here the Lord idea of a measurement, which comes from the Goetz conceptualization of concepts. And in this case, a specific case is the question from a survey study and a variable. And what you can see here is that the metadata for these variables and questions are available, and then we add a concept to both of them because the question and the variable together form the measurement and they relate to the same concept, of course. This is specific to survey data. You could also have a kind of information abstraction from text data. Then, of course, you would not have a question text to some extent, but methodological definition. And we added the has dimension to the data model because related broad and narrow from SCOS are not exactly what in social sciences is meant when we talk about concept specification with dimensions. And this is an easy example where you see that most of what we did already exists. So we have identifiers for the variable. Here the example is in German. I apologize, couldn't do it myself, so I had to take what we had. But the question here is simply the question how left or right you would evaluate the social democratic party of Germany. So here is a variable with the variable name, so the data set, the variable name, and here you have the concept, and these concepts are two concepts for the very same thing because you have the self-right judgment and of course also the ideological position, because depending on the context you will have different theoretical words used to it. And this is the basis for the triple store that we developed. And because we wanted to have a first step into the reality of data documentation, we developed, especially my colleagues from the computer science department, developed an annotation tool that would allow you to link the metadata, the concepts to the metadata. So what we have here is the perception of your own economic situation, which is a question that relates to the theoretical frame of economic voting. And what we have here is the metadata from the measurement, so from the questionnaire, and here from the data set, so that we can compare them. Sometimes this is important because questions are divided into a lot of different variables. And what we have here is that we linked our annotation tool to the Thesaurus Social Sciences that was developed by GESIS, but it's not, and let's say, maintained anymore, and you could choose terms from the Thesaurus, or you could add your own terms for concepts if it was lacking. And we have an automatic query extension so that you see what concepts already exist in the database. So what we wanted to do, I jumped the triple store because I can't show you a lot of the triple store, it's just a database and it's not very interesting. So what we wanted to do is to have 3 different survey studies from Germany and to do a test annotation. And the idea was that all team members annotate all sample questions from all 3 surveys. So the first is the German socioeconomic panel, the second is the German general social survey, the IASSIST, and the third is a study from higher education, the National Academics Panel Study, which is basically a survey of graduates. And we selected questions on specific topics so that we have a little bit of overlap, and we wanted to ask if there is, after annotation, substantive overlap, or if there are parallel structures emerging, and if the annotation of the questions brings a concept structure to the world, an emerging structure that allows you to understand the relationships within the data. And what we see is that indeed the different annotators do their work very differently. So here we have a very simple example. It's the Big 5 inventory of personality traits, and there is one major topic is personality, or Big 5 inventory, which is a more theoretical term, and then you have the 5 different personality traits. But one of the annotators, for instance, selected the theory terms and the measurement terms. So one extra version and then Big 5 extra version. And if you add them up, it looks messy, but in the end you have a clear structure because all the items were, or you have links between the concepts, and these links between the concepts emerge because they have been linked to the same variables, okay? So the general topics, personality, personality trait, big five inventory, are used substantively, consistently, and then also the 5 different personality traits. But this is still different. What we would love to find is, of course, the pattern for annotator 2 for both annotators, which is not the case. And then what we see is that we have more general terms that have been used very intuitively by the annotators from the project. So, for example, the health status has been used to annotate quite different concepts, like the existence of a handicap, a physical handicap, but also psychological diseases. What we do not have available at this moment is that you can create links between the concepts. Also, this is part of the data model, this is not part of the annotation structure, but overall, we are quite satisfied with the results. So, what are we going to do? The thing is that we only had a 1-year pilot phase funded by the German Science Foundation. And what we now want to do is to design a concept registry that is more comprehensive. And what we learned from our pilot phase is that we need more support for individual annotators in order to limit the diversity of the different terms that are used for annotation. So what we see, for instance, here, the different terms used for personality traits should be harmonized into preferred terms, otherwise it doesn't make too much sense to have a lot of redundant terms into a concept registry. But we don't know how to do it because we don't want to have a full curated workflow. We want to have this openness to input from the users. So a user-driven concept registry will require a performance recommendation system. This is something that will be at the very core of the future project, probably, if it's funded. And of course, the probability to create links between concepts, so to have a curation of concepts included. And my assumption is that in the start phase, we will need a lot of work to find the relationships between the concepts and to include them in the system before it can work independently. And what we want to do, of course, is also to use the concept registry metadata that is stored there to support search for concepts, also automated search for data that are related to specific concepts. And this final product could look like that, so that we have the concepts here and we have an annotation tool in the middle, and users, data professionals working at research data centers, this is our target group, would add the concepts to their measurements. New concepts are added to the LORD concept vocabulary, and then the metadata and the concept goes to Triple Store, and the Triple Store feeds a recommend application. We have we did some experiments with similarity measures that were created by an algorithm that could help. If you feed metadata into the Triple Store, then it would see that a question is very similar to another, and then it could recommend the concepts that have already been attributed to this question. And then we would love to have an exploration engine where you have a graph-based exploration of the data. And this could look like a very fancy thing where you start with a very general topic like health, and then you can go to always more granular topics, and then finally to the variables. So this is our plan. This is what I wanted to show because I thought IASSIST would be a good audience for these kinds of ideas, and we are quite happy to learn about people that did similar things or are doing similar things or would need similar things, so that we have a good discussion about how to join forces. But of course, this is not something that is limited to a national frame. Thank you very much. I was in time, but only a couple of seconds left for
Perfect,
questions.
Pascal. Perfect. Do we have any questions in the room? James, do we have questions online? We'll get them all at the end, I think.
Okay.
All right, we'll take another beat. Okay. All right. Thank you so much, Pascal.
Okay, well, our next speakers are getting themselves set up. Let me introduce Bita Lichtwart and Christina Magder. Bita works in user support and training and the Secure Lab at the UK Data Service, UK Data Archive, University of Essex. She is a quantitative social scientist, just like me, having formerly worked at the Max Planck Institute for Human Development in Berlin and the Institute for Social and Economic Research at the University of Essex. Bita represents the UK Data Service in the International Data Access Network, IDAN, and has been the UK Data Service lead for SSHOC WP 5.4, Remote Access to Sensitive Data, and is a co-chair of the International Secure Data Facility Professionals Network, ISD-FPN, as well as a steering group member. Christina Magder is the Data Collections Development Manager at the UK Data Service. In her role, Christina ensures that key data are effectively identified, negotiated, and appraised for research and teaching. She leads the research data management portfolio of support and training for the UK Data Service, with a particular focus on facilitating the implementation of the UKRI research data policy for the ESRC. Christina is committed to further helping to build the culture of fair data sharing and to empowering researchers to make informed decisions about how to best manage and share their data. Please join me in welcoming Bita and Christina.
Thank you very much for the nice introduction. I will now be talking about enabling reproducibility in secure data facilities. This is a talk I have prepared together with my colleague Christina Magder. And our roadmap for today will be as follows. We will first focus on the current situation regarding reproducibility in secure data facilities. We will then have a look at the journal requirements as we know them. And we will then focus on how do we see changes evolving in the current landscape. Does this require new solutions potentially? And how could they look like? So we have two scenarios, which are basically two solutions that we could see. One is that a reviewer could be allowed at a secure data facility. Of course, we are now focusing on UK Data Secure because that's our TRE that we are working in. But this is also something that could be generalized. So that would be one solution. And another solution could be a reproducibility service that can be established at TREs. We will finish with an outlook and a discussion. And the discussion will be a bit different to what a discussion usually looks like. So that's an interactive part. Please keep your mobile phones handy. Usually it comes at the beginning, something like an icebreaker, but we do it at the end. We just reverse it. Now, what is the current situation regarding reproducibility in secure data facilities? Well, it's pretty simple. It's not possible. So at the moment, reproducibility is not an option when it comes to scientific research based on personal, confidential, and sensitive data. And we will refer to that as secure access data. These are usually held and made available via secure data facilities. And I will also use the term trusted research environment. This is commonly used in the UK. It has an additional layer to it, which basically means that it's based on the 5 safes. But I use these two terms interchangeably, so secure data facilities and TREs. So normally, these secure access data can only be accessed via a multi-staged application process that is quite lengthy and that involves many steps. And this is really important, only for research purposes. So what is the current situation? How do researchers and journals work around the normal requirement of reproducibility? Well, a commonly accepted way is that the code, the syntax, can be submitted together with the paper, with a publication or publication to be. So researchers, when they ask the TRE for their output, so basically request an output, their analysis that has been done within the TRE, they can also ask for the code or for the syntax to be outputted to them, which will be done after the normal process of an SDC check, statistical disclosure control, sorry. So that can be given to them. And so normally they would just submit the code together with their paper to the journal. And here we have one example. This is a PLOS, is a peer-reviewed open access journal. published by the Public Library of Science since 2006. And just a little snippet of their terms and conditions when it comes to reproducibility. So basically the journal requires authors to make all data necessary to replicate their studies findings publicly available without restriction at any time of publication. Well, that wouldn't be possible with secure access data, right? However, they also make allowance for exceptions. So they continue then, when specific legal or ethical restrictions prohibit public sharing of a data set, authors must indicate how others may obtain access to the data. And then further down, they also basically say that PLOS recognizes that in some instances, authors may not be able to make the underlying data set publicly available for legal or ethical reasons, etc., etc. And where frameworks prevent or limit data release, authors must make these limitations clear in the data availability statement at the time of submission. So basically the way out here for the researcher is to provide a data availability statement. And we have put together an example for you how such a data availability statement could look like. And here you can see the Millennium Cohort study has been used from the UK Data Service. So basically here, they can clearly say, okay, I cannot make the data available, but you can actually get the data via the UK Data Service. It's a lengthy process, but actually is not possible for just replication and reproducibility purposes. Just one word for the how we define reproducibility and replication, because very often these terms are used interchangeably, and they are also used differently for different disciplines. So just to be very, very clear that we basically use for this presentation the terminology that is commonly used within the social sciences, where reproducibility means to generate the same results using the original data set and the same code used by the original researcher. So reproducing the results with exactly the same data and the same code. Whereas replication would be to achieve a similar result with different methods or slightly different methods. So we are talking about reproducibility here. And that is actually, that was also meant by the journal, but just to be very clear about the definitions. Now, so far so good. One could say, well, it's all working, what's the problem? Well, actually, the landscape is changing. And well-established secure data facilities like the UKDS Secure Lab, which exists now for more than a decade, are increasingly receiving inquiries to enable robust and transparent reproducibility. And we are also asked to facilitate and assist peer reviewers prior to a journal article publication. And this we observe especially for economics journals. So this is where it actually comes from at the moment. The request that a reviewer will be allowed to basically reproduce the findings. Now, in this context of a very fast evolving secure access data landscape, reproducibility has become a growing concern for journals. I mean, it's a normal requirement for any other research that there should be the option to do this bit to basically by the peer reviewer to allow reproducibility, which isn't the case, hasn't been the case so far for secure access data. And so this is a growing concern for journals, researchers, and data service providers alike. And Christina and I have put together two possible solutions that we could see here. And we will develop and examine these solutions together with you now in this talk. And basically, how could secure data facilities handle the new reproducibility requirements for secure access data? And we will also discuss the very practical implications of both suggestions. Now, what could potential solutions look like for this dilemma, if you wish? So, scenario A, or solution A, could be to allow direct access for peer reviewers to the secure data facility. And I will come to this in a minute, what exactly that would mean. And the second option would be to have a certified reproducibility option provided by a tailor-made service within the secure data facility. So our aim today in this short presentation is basically, in the short run, to outline how secure data facilities can support the peer review process a little bit better. And in the long run, to help pave the way for enabling reproducibility of scientific research based on secure access data. So let's just talk about the situation at the UKDS Secure Lab, the TRE that exists for more than a decade. We start on the top in the circle, original data within the TRE, and then we move clockwise, not anti-clockwise, clockwise to the next step. So there is the original data within the TRE. The researcher analyzes the data, the secure access data within the TRE. Then the output is requested by the researcher. The TRE staff is processing the output request, doing SDC checks, statistical disclosure control checks, and then outputting the code and the research output to the researcher. The researcher then submits the article and the code to the journal, and if deemed fine, it will be a publication. This is the current situation. Now, how would that look like if we had solution A? So if a reviewer was allowed at the UKDS Secure Lab, for example. Now, we also had a circle here, but we had too many circles and you wouldn't be able to read it, it was too small. So in order to make it accessible, we have now these boxes. So basically we start again, original data within the TRE, then the researcher carries out the analysis within the TRE, the output is released to the researcher by the TRE following the SDC checks, and then that is submitted to the journal. Now comes a new bit. The reviewer applies to access the TRE for reproducibility purposes. At the moment, that is not possible, and I will discuss in a minute how we envision that could actually become possible. Now then the reviewer would run the researcher's code via remote execution, so they wouldn't have access to the complete original data set, and but they would, of course, run the code on the original data that the researcher has used, and then they will basically do the reproducibility checks. So they would have the paper that was submitted to the journal, and they will have the code that they run and see whether they can actually reproduce the results that were submitted to the journal. Now then the reviewer feeds back to the journal whether that was successful, and then the publication process can go ahead if the finding was that it was reproducible. So that would be scenario A. Obviously that doesn't come without challenges. And these challenges are fivefold, if you wish, and they move along the factors time, access, costs, single and double blind reviews, and technical arrangements within the TRE. So what exactly does it mean? So basically time. Well, the application process for secure access data at the moment is about 3 months. It can be longer in other countries, for example, it can be also 6 months to basically get access to these data. It is, as we said in the beginning, a multi-staged application process. It includes researcher training, etc., etc. So there's not much that can be done to reduce it down to a very short time. Now the publication process is already quite a lengthy one, and if you now add another 3 months for a potential reviewer to basically get access to do the review and to try to reproduce the findings, that actually adds to it quite considerably. Now, what would be a possible solution is if there was a new streamlined process for reviewers. So that actually, it wouldn't take 3 months if there would be a different process. Now, access. I said in the beginning that at the moment you can only have access to these kind of data for research purposes. So we would need to get the data owner's approval to grant access for reproducibility purposes. However, a potential solution could be that reproducibility could become a key component of the deposit license agreements. The next point is costs. Obviously, we would need to train researchers to put their code together in a way, or basically clean it in the end, so that it really is fit for the purpose of reproducibility. Very often you have a code, and actually if you run it, then you would get much more than what is actually included in the final publication. So that would actually need to be cleaned and only produce exactly the results that are submitted to the journal. So it would need to be really ready for this sort of purpose. We would need a bit of funding to train researchers to do that. But I think this funding is considerably less to what we will see for the other option. Now then there's a problem of the single and double blind review. So according to the DEA, the Digital Economy Act, accredited researchers and accredited projects need to be in a public register. So then obviously it's not possible to have single or double blind reviews because the details would be out there. However, the DEA also allows for exceptions, and these would classify as exceptions potentially. So that could be a solution, a potential solution that basically then maybe the researcher would not be named. And also the other thing is if the reviewer then is added to a project, usually that cannot be done anonymously. Again, there would need to be some ways around that. And finally, there are technical arrangements to be done. So to basically allow access to a specifically set up project, for example, where you have the publication to be and you have the code that basically can be run, and then find ways around, but it's possible technically to basically do that. Okay, so these are the challenges and potential solutions. Now scenario based, so basically the solution number 2, how about establishing a reproducibility service within the UK Data Service? So basically a service within the service, a reproducibility service established at the UK Data Circular, for example. And again, how would that look like? So we start again, we have the original data within the TRE, the researcher analyzes the data within the TRE, output released to the researcher, submission of the article to the journal, and now the journal requests the reproducibility stamp. So tell me that this is basically adhering to the reproducibility requirements. Then the in-house reproducibility service would run the researcher's code on the original data within the TRE, would then do the checks, feedback to the journal, and then the publication could actually happen. Now, of course, also that has challenges associated with it. And again, we have the same factors here, as you can see on the left-hand side. So obviously, we would need much more funding to establish a reproducibility service. Also, there would be different setups needed for that. So you can see that here under solutions, when talking about establishing a new setup for a reproducibility process, only providing access to the code necessary to reproduce the results used in the publication, but also there needs to be something else that basically you would not have the sub-service to be established linked to other core services within the service. So that's a little bit more complicated, but there is an interesting pilot out there. And that is the French Reproducibility Certification Agency, Cascade CSD, for example. And I don't have time to talk about that in more detail. And I also don't want to talk about that in more detail today. However, I think it is really worth having a look and reading a little bit more about it. And it gives definitely food for thought. It's a non-profit agency. And obviously, the goal here is to provide the researchers with an innovative tool, basically allowing them to signal reproducibility of their research. And I think this is what exactly both of our solutions are meant to do, to signal the reproducibility of their research based on secure access data. And that's something that's not possible at the moment, but that would actually signal it. The other thing is, it would be interesting to see how much it will be taken up, but the option would be there. Okay, now, so the outlook basically is on the top, the two boxes you see here. This is basically what is already done at the moment. So the code is, or the syntax is submitted to the journal alongside with the actual paper. And the paper includes the complete data citation, which also includes the DOI. So we do not output any research outcomes without having the proper data citation, including the DOI included in that output. That's one of our rules. So basically these things are already done. That goes to the journal at the moment. However, in future, and in the nearer future, we will determine the feasibility of reviewer access to UKDS Secure Lab. And in the longer run, it would be worth considering a reproducibility service for the UKDS Secure Lab. And I'm talking here about the UKDS Secure Lab because that's a TRE I'm working in, and basically this is the one for which we are considering these things. However, these are generalized or generalizable solutions for TREs, no matter where. So that's an interesting discussion. And talking about discussion, we would like to hear from you. Please, can you use your mobile phone to scan the code or go to the URL that is provided here? We would really like to hear from you. It's a very short thing we are asking you to do. In the beginning, you can actually take a little needle and point it on a world map from where you are. That would be very helpful, and actually it's a fun bit. And it's really just very few questions. It's quickly done. It would be lovely if you could please do that. Right. Now, I don't know how much time we have for discussion. I think maybe 2 minutes. Are there any questions?
I think we can take one question because we're right at time, but I will indulge Ron because I love him.
Hi, thank you very much for your presentation. I like the way you laid out the two scenarios and the challenges and the possible solutions. Solution B reminds me a lot of what Sizer at Cornell has done for the American Political Science Association. So it's a proven model that really has contributed a lot, but it requires buy-in and support by something like the APSA and their journals. So it's really more of a publisher kind of driven solution. I don't know what the landscape of the vendors or publishers in the UK are, but can you share at this stage sort of which of the two solutions feel like it has the highest likelihood of success to be implemented at this time?
Well, actually, obviously, the first one is more viable due to the cost, which are basically much lower than the second one, right? So, I mean, the first one is something we are actively considering, and we are looking into what are the ins and outs, or what are the little technical details that we would need to consider, and actually that's something that's feasible. So I think when you watch us, that will be the first step. The other one is actually quite a nice idea, because it's something like this. I mean, you said it's already there at Cornell, and please get in touch and tell me more about it. But that's obviously something which. Let's start from a different angle. When we do our SAFE researcher training, researchers ask already, so how can we actually meet the requirements for reproducibility when we want to publish? And at the moment, as I laid out, it's still okay to provide code for most of the journals, but actually it's, as I said, especially the economics journals are now starting to require more, and they actually want reviewers allowed in the TRE to basically do the reproducibility bit. And this is what we are working on at the moment. However, I find also the other solution actually quite interesting, because that could actually cut the time down to quite a small amount of time that is needed for a reviewer from this particular service to basically very quickly do this sort of service. So I think that would be a much quicker procedure once it is in place.
We have a question online.
A question online.
Yes. So this is a question from Stefan Kramer at American University. And Stefan asks, in scenario B, if reproducibility in running code against data fails, and the service has questions about the code for the researcher, would they get in touch with them directly, or would that be done via the journal publisher? And I just wanted to mention, we really just have about a minute left, so.
Actually, that's food for thought for me. I haven't thought about that yet. So actually, that's a very interesting question, and I can't answer it. But I would like to hear, for example, the speaker before, the gentleman who asked the question, would you have an answer to that?
I can answer that.
Floria, you want to come up?
Ron was referring to our service at the Cornell Center for Social Sciences. It's a results reproduction service where we reproduce our researchers' results prior to publication. And so if in a scenario where it is in a secure data environment, and our service was used to reproduce the result, we would be contacting the researcher in this case to figure out what the cost is of the differences in results or errors in the code and so on and so forth. We'll be working with our researchers.
So you would contact them directly? Yeah.
Correct.
That
Yeah.
sounds, yeah.
Yes.
Okay. Sounds good.
All right, thank you, Bita,
you.
and thank you, Christina. We're gonna switch one more time to an in-person presentation. So I'll chat while the tech person comes and gets our stuff set up.
Thank you very much.
All right. I guess I can just use this mic. Our final speaker today is Dan Gilman. Dan Gilman works in the Office of Survey Methods Research at the U.S. Bureau of Labor Statistics. There, his research interests include metadata, standards, and transparency. At BLS and the parent Department of Labor, he is a consultant to the program areas and agencies as they embark on metadata management and transparency activities, some for the first time. Today, he will talk about plans he is helping the National Longitudinal Survey at BLS develop to use DDI to build a metadata system for a new cohort, scheduled for 2026. Dan has spoken at many prior IASSIST conferences, and he is one of the team of the developers for the new DDI cross-domain integration standard. Today, Dan will be speaking on using DDI lifecycle to document the BLS National Longitudinal Survey of Youth. Please join me in welcoming Dan.
Thank you, Ashley. So let's see if I can never make this work. Okay, so a little bit about the National Longitudinal Surveys, if you're not familiar with them. They're a set of surveys designed to gather information at multiple points in time, so longitudinal, on the labor market activities and other significant life events of several groups of men and women, and actually youth as well. So here's a table of what has been done in the past around NLS, and there are 4 cohorts that are continuing. Several others have also been ended, but there's a new one planned for 2026, and that's kind of the focus of what I want to talk about today. So the 26 cohort, BLS is currently in the process of planning for a new youth cohort, the National Longitudinal Survey of Youth in 2026. And this will enable us and other researchers to examine lessons learned from the previous cohorts and permit the study of new factors affecting lives and labor market experiences for a new generation. So it's timely. We haven't had a new cohort for a while, so this is the right time. So Like I said, there's a new cohort plan for 2026, and so the big change that BLS wants is full control over the system that's built for disseminating data and the metadata for describing them. We want to have the metadata better integrated into the system. Right now, all the ideas are in the planning stage. We haven't implemented anything, but there is one decision that's been made, and that is they want to use DDI. So I think that's pretty cool. Current state is that we have a lot of documentation for each of the cohorts. They're on multiple pages throughout the BLS website. The nice thing is that the documentation is consistent across the various cohorts. So if you go into the documentation, the look and feel is the same. They've got the same tabs and links to various aspects of describing the surveys. So in that sense, the documentation is somewhat systematic, and it's reasonably complete. There's a lot of information there. But some of this is on the BLS website, and some of it is on what we call the Investigator, which is the data dissemination tool for NLS, and it's on a separate website managed by the contractor that built the tool. And that, in a sense, is part of the problem. And none of the metadata is machine actionable. So the dissemination system is through this tool we call Investigator, and is built by a contractor and maintained by the contractor. It provides full access to the public use variables, questions, groups of questions and variables and code books. A problem for us, though, is that the underlying metadata schema, the way that the contractor organizes the metadata and questions about updating it and making it more useful in some way, is not available to us. We don't really understand why, but it's not. So what does Investigator look like? Well, this is going to be hard to see, but so there are a bunch of tabs towards the upper left, and I've selected the variable search. And when you do that, you get this menu of topics. And so what I've done is I've opened up the employment history tab and got down to employment, sorry, I can't read this, but I think it's employment status. And what you get is a group of basically 52 variables that are associated with each of the waves of the study. This happens to be the 1997 cohort, and that's daunting. But then worse is when you click on one of those years, one of those waves, then this opens up 52 variables. And so the combination is 1,381 variables, which is, and for one subject, which is basically employment status on a weekly basis, which is an enormous number of variables to try to make sense of. Then if we mouse over one of those variables, we pull up what's called the codebook information, and what this does is it provides basically the value domain, the set of allowed values for the variable, the question that gave rise to the variable, and some other information. It's not quite complete, though, because if you click on the codebook tab, you get the same information for the variable that you've selected but you also get information about what's missing, the missing value codes. Why that isn't in the mouse over, I'm not sure, but as you can see, this is not machine actionable. It's just text. So as I said, there are 1,381 variables, basically for just one idea, which is the weekly employment status. And this kind of duplication repeats itself for all the variables that are in the survey when you're comparing wave to wave. The value domain, the set of allowed values for the variable, though, remains the same, at least as far as I could tell. Now, understand this, in order to see what the value domain is for each of the variables, I have to go to each one and inspect it. Okay, there isn't any way to kind of automatically compare the value domains across these variables. I have to go into each variable and pull up the value domain. There's no access to them. It's just what I can see by mousing over or going to the code book. So this is time-consuming, error-prone, and pretty tedious. However, from what I could tell, the value domain never changes. So, and sometimes for other variables, they do change, but they don't change often. And so there are a lot of variables within the investigator tool that, from a metadata perspective, are really very much the same. So the DDI provides a nice framework for describing variables called the variable cascade. And DDI lifecycle and the new cross-domain integration both have the cascade as part of the specification. So if you're not familiar with the variable cascade, it divides the description of a variable into reusable parts. The highest level is called the conceptual variable, and it basically describes the concepts that are used by a particular variable, the concept that the variable measures, and categories and numbers that are used to represent values. The representations are at the represented variable level, so there the full specification of the value domain, the set of allowed values, is provided. And then at the application level, they call this the instance variable, and that has some additional dependencies associated with the application. So, as I said, 1,381 variables. It's basically the number of weeks over a large number of waves. I think I counted it right, it's 27 in 1997. And it's the same value domain for the weekly employment status. So basically this means that there is one represented variable describing all 1,381 variables. So you can do a lot better from a metadata perspective by just providing that one thing rather than this whole slew. So they all share the same represented variable, RV. The instance variables, that is at the application, vary by a little bit. For one thing, the data set is defined by investigator, so they all have the same data set, same data type, on and on. The only thing that really changes is the wave and the week. And so we really only need the one represented variable plus information about the missing values to basically understand what all those variables look like. So we also looked at another variable, the reason the respondent left a job, and they call it YEMP-58400. Don't ask me why. And here the value domain does change over some waves, right? But there are really only about 5 different represented variables over all that time. The changes aren't that common. And so again, the level of variability, sorry the pun, that you need to describe that 700 variables describing the reason the respondent left is reduced to about 5. And this reduction, I think, can really help the way that we present the documentation about variables for the NLS. So DDI lifecycle is the main part of standard under DDI that's been selected. And given that life cycle has the variable cascade, it makes sense to use this. And life cycle also provides machine-readable descriptions of several other things: sampling, weighting, questionnaires, the design and the flow, groups of things, so you can group variables, you can group questions, you can group all kinds of things, you can group groups, and data sets and so forth. Investigator doesn't appear to have this flexibility or extent. Basically, it is what it is. You get this long list of variables, you get to mouse over and see some metadata, but it's not integrated into a system that allows you to use the metadata really to find things. The only aspect of metadata is the subject headings that we have, which are good, okay, but it's not the whole thing. So as we just said, the NLS covers many subjects, and the topical guide links users to the detailed documentation, covers variables and how to use them to describe each subject, includes some details about how the questions were asked, as I've indicated, and it contains a link to details about the value domains. But, and a lot of this documentation, of course, is worth preserving, especially that which is at BLS. But, as I said, it's all text. It's not machine actionable. So this is a problem, and it's among the things that we're looking at. So this is just a picture of what the subject headings look like. And when you click on them, you get to more detail, and you can dig down. And I think there are nine of them, plus this thing at the top, the asterisk tables. These are special tables that exist to describe certain things within NLS. But continuing, because NLS is a longitudinal survey, it contains event histories, because you can see what's happened to a person in the cohort. You can track their education, you can track their employment history, you can track their marital status, program participation, and these are special areas that we have event histories called arrays that exist to allow researchers to be able to track these events over time. But we also want to consider some aspects of the cross-domain integration as well, because first of all, as many of you know, cross-domain integration is not yet a published standard, but it's been developed, and it's at the technical committee of DDI for final consideration before a vote goes to accept it as a standard. And one of the things that it contains that Lifecycle doesn't really contain is the ability to describe structures of data. And so there are four main types. There's the wide, which is the rectangular way, the Excel spreadsheet that we typically use when we look at microdata. The long, which is the event history, so that's kind of think of the units, instead of the units being the rows, they're the columns, and the variables of the rows instead of the columns in the long. The multidimensional structure, especially for time series and aggregated data that's cross-tabulated, and then key value pairs for web scraping and other ways of getting data that are not typically from a survey. So the event history structure improves the handling of histories. It's designed for that. We can increase the usage of histories probably beyond what the four categories that we currently do, because there are other histories that we could document in the survey. Interestingly, I think that the multidimensional data structure might be useful for simplifying the way that we have all these variables for one subject. Because going back to the weekly employment status, we have over 1,300 variables. The only things that differentiate them are the week and the wave. Well, you can think of those as dimensions in a cube. And so we just use them to classify basically one variable, because it's always the same, and then the data that's associated with that is just in this big multidimensional structure, and we can probably access and analyze the data more directly that way, and it's easier to process. So, and we also have the ability to look at provenance and detailed processing in CDI that goes beyond what Lifecycle has. So that's what I wanted to say. I don't know how much time is left, but if you have questions, I'm here to answer them.
Thank you, Dan. Do we have questions in the room? Yes. Do you have any questions in the room? I'm looking at Jim if we have any questions online. And I can, if I switch the source, will I switch it back to there we are. We got it.
I waited to see if anybody else. Hi, Dan. This is very exciting. Having helped different researchers where I'm at try to figure out how to use the investigator interface to get stuff. I think hopefully, potentially, this is going to be a great improvement. Can you speak a little bit more about any kind of potential or even planned timeline? Or will the investigator developers, are they open to implementing DDI, CDI and restructure the way they present the variables in their interface?
So that's a really complicated question. And I'm not really in a position to answer it directly. I think we'd need some of my co-authors here to talk about that. But the basic idea, as I understand it, is they want to build something new.
Any other questions? I don't see anything in the Zoom. And it is 5 o'clock, and so the poster session is about to begin. And so I think that means we should just conclude our session on time. So thanks again to all of our speakers. I think this was a really wonderful session. I learned a lot. I really appreciated hearing from everyone. Please, one last final round of applause.